Apart from making Tinkercad tip videos, one of the things that I do here on TikTok is show you guys how I make filament out of these plastic bottles. But I do have another hobby that I wanted to show you today. One of the things that I like to do in my so-called spare time is to make these all-weather wind chimes. Now, I found a company here in Phoenix that works on fire extinguishers. They empty them out, refurbish them. But a lot of times these fire extinguishers, the canisters are either too old or they have dents in them and they can't be reused. And I got a hold of this gentleman that owns that company, and he gave me a number of fire extinguishers, this one here being the largest. And I've been putting together some of the things for the chimes, like the sails. This one here is a large clapper for that large purple chime that I showed you. But I need a couple more large sails. So today I'm going to be working on some of these bottles. Here's the empty bottles. We get these from a friend of ours. And then I expanded them with a little bit of pressure using a Schrader valve and my air compressor. Cut the bottoms off, and then last night I colored the inside of these with some purple Indie ink. So today I'm going to cut some of these up and run them through my pultruders. Let me show you that. Now, this is the bearing cutter that I use to turn these bottles into ribbons. It's a couple of sharpened bearings, one edge set on the other. And then I use the scissors to kind of start the cut on one of the bottles, like this one here. And then I wind them on the spools, and I use this little machine here. Let me cut over and show you the pultruders working on some filament right now. So these are my pultruders. These are the Recreator3D MK5’s. The plans for these are available on printables.com. These can be built by using basically the guts of the components of an old Creality Ender 3 3D printer. All the plans are up on printables.com. I will, I guess, provide the link in the description of this video. Anyway, I've taken those bottles and I've cut it into ribbons, and I put them on these small spools here, loaded it into the machine, and basically like a 3D printer, I'm just running G-code. I actually designed this Marlin OS myself, and then the G-code that I run to pull these. You can see the ribbon here going into the back of the hot end. And you'll ask what the nail punch is for. The nail punch is to keep the ribbon from flipping over inside of the hot end. Inside that hot end, I have this nozzle, which has been drilled out to just slightly under 1.74 millimeters. And then it pulls it through, basically using, in this case, a couple stepper motors on this big gear system. And it very slowly just warms up the filament, curls it over into sort of a tube shape, and it exits out of that brass nozzle there. I said I have 3 of these going. Makes it a little more efficient. I've got 10 of these purple bottles to make. I've got some large sails to print up for those chimes. This just makes it a little more efficient. Got another one going. Basically, it's the same Marlin OS that I designed in G-code. Third one over here. Now when I'm done with all of this filament, I'm going to take it all and run it through my Slunaz FF1R. It's a filament joiner, and I can show you that in just a moment. Now here's some of the filament that I just took off one of my pultruders. It's ready to go. But one of the things that I do, one of the tools that I have in my arsenal, is I check all of this with a filament diameter gauge. I made this partially 3D printed. The gauges themselves I got on Amazon. And what I've done is I've calibrated this to show that as I pull this through here, that the filament is the correct diameter. If it's not the right size, if it's too small, let's say, it won't go through the extruder of my printer and the print will fail. Let me show you how this works. Here I have the filament put in, goes into the side of this one, the side of this one. and it gets run between two roller bearings there. And then the gauge up here shows me the diameter. And you'll see as I move this filament through here, the gauges move, because of course the diameter changes a little bit. But so long as that stays close to that section I have marked out, the filament is the right size. If I find anything that's too small, I'll cut that section out because I don't want it to ruin a print and have a long print fail. Well, it took the better part of the afternoon, but I finally completed 10 bottles, so there's 10 sections of filament here. Each one of these sections of one of those 1-gallon bottles is going to be roughly 13 to 14 meters. So now I need to take each one of these, process it through my filament joiner, the Slunaz FF1R, and put them on a spool, and then I will put it in my dryer overnight, and then I can begin printing with this tomorrow. So let's go check out the joiner. So this here is my Slunaz FF1R filament joiner. This is more of a professional model. And like most of the joiners, there is a bit of PTFE tube in here and a heater cartridge. But this is all automated, and as the filament goes through, it'll spool it up onto this take-up spool here. So I need to make a few settings here. I'm going to set this at 257 degrees. This is a profile specifically for PET filament. I'm going to do a 60-second cool-off period, a +2 overlap. All right, now I need to start the filament in here. Now I'll let the machine run and I'll get this first section of filament onto this spool. All right, there I've got the first section started on the spool. I've got my next section of filament here, and they make this super easy. All I need to do is feed it into this side, get it started here. The joiner will grab it, and it's going to butt the two ends up against each other and heat them inside that PTFE tube and allow them to cool. I'm going to press the check button here, so when it's done and it ejects, it'll stop here so I can check the weld before having the machine wrap it up on the spool. There's the end of its heating cycle, going through a cooling cycle, and in a moment here it'll move forward just a little bit. Halfway through its cooling cycle, and when it's finished cooling, it'll eject, and I'll be able to check that weld before allowing it to wrap up on the spool. This thing makes a really great weld. It's 2 or 3 millimeters long. It's a really solid weld. Much better than I used to do with a soldering iron and just joining the ends together. There's the end of the cooling cycle. And right there's the weld that it's made. Let's do a quick close-up. And here's that close-up of the weld. Let's see if I can get it to focus here. You can see that whitish part there. And that's a good 3, maybe 4 millimeters long. A good strong weld. Now I'm going to go ahead and wrap that up onto the spool, and I've got, what, 9 more of these, 8 more of these to do. All right, just finished with the last of the sections of filament. Got 10 of these all joined together. Let's go pop these in the dehydrator. This is my filament dryer, basically just a dehydrator, but it works really good for drying filament, just the right size. Pop my spool in there. I have this separator tray that goes on top. Throw the lid back on it. We'll start this up, and in the morning this will be bone dry and ready to print. Well, it's the next morning. This has been drying overnight, my dehydrator here. Let's get the filament out. Let's go hang it on the printer and get cracking. Well, it's done. That took about 4 or 5 hours, but it's completed. Looking really good. Let's pop it off the build plate here. Pops right off. Got sort of that matte texture on the back. It's about 3 millimeters thick, and boy is this thing strong. This is gonna look great on that wind chime. Well, there you have it, folks. A little recycled PET from plastic bottles made into something totally useful.